So, good day once again, ma'am. My name is BLESSY ATIS Ilajas from BSEE 1A, and today I'm going to explain my answer on how I derive my answer and my explanation kung giunsa na ay kung unsa ko pagsabot since ang kaning problem set given is nana siya sa book. So, ang ako lang is explanation kung giunsa siya or based lang akong nasabtan. So so we are now on lecture 4 and the topic is series and parallel circuits. So problem set number 1, example 10.2 on page 442. So equivalent resistance, current, and power in a series circuit. A battery with a terminal voltage of 9 volts is connected to a circuit consisting of 4 20 ohms and 1 10 ohms resistors, all in series on figure 10.13 sa book. So assume the battery has negligible internal resistance. So so these are the given from the problem set. So the resistance 1 or the R1 is equals to 2 ohms, R2 is equals to 2 ohms, R3 2 ohms, R4 2 ohms, R5 10 ohms, and V is equals to 9 volts. So as we can see in this figure 10.13, so same sa morning R1, R2, R3, R4, and R5. So in this series circuit, the equivalent resistance in algebraic sum of the resistance, the current through the circuits can be found the Ohm's law and is equal to the voltage divided by the equivalent resistance. The potential drop across each resistor can be found using Ohm's law. The power dissipated by each resistor can be found using P is equals to I squared R, and the total power dissipated by the resistors is equal to the sum of the power dissipated by each resistor. So the power supplied by the battery can be found using P is equals to I E. So excuse me. So solution, letter A. So the equivalent resistance is the algebraic sum of resistance. So R equivalent, so the resistance equivalence equals to R1 plus R2 plus R3 plus R4 plus R5, in which is equals to so 20 ohms plus 20 ohms plus 20 ohms plus 20 ohms plus 10 ohms, in which is equals to 90 ohms. So muna siya ang equivalent resistance. So imo na siya i-add ang mga resistance. So next, letter B. The current through the circuit is the same for each resistor in a series circuit and is equal to applied voltage divided by the equivalent resistance. So I is equals to V over the equivalent resistance, in which ang atong V is equals to 9 volts and ang atong equivalent resistance, since nakita naman nato, is 90 ohms, in which ato siya i-divide, and then we can get 0.1 ampere. So letter C next. So the potential drop the potential drop across each resistor can be found using Ohm's law. So V1 is equals to V2 equals to V3 equals to V4 equals to 0.1 ampere. Excuse me. 20 ohms, in which equals to 2V. Then ang V5 is equals to 0.1 ampere times 10 ohms equals 1V. Then V2 plus V1 plus V2 plus V3 plus V4 plus V5 equals to 2V plus 2V plus 2V plus 2V plus 2V plus 1V, in which equals to 9V. So, excuse me, yupo juga pa. So, next the letter D. So, the power dissipated by a resistor is equals to, blurred naman siya, P is equals to I squared R, and the power supplied by the battery is equal to P equals to IE. So, excuse me. So, the P is equals to IR squared is the power dissipated. Then P I is equals to P2 equals to P3 equals to P4 equals to 0.1 ampere squared times 20 ohms, which equals to 0.20 watt. Excuse me. Then ang P5 is equals to 0.1 ampere squared times 10 ohms, and which equals to 0.1 watts. So the P dissipated equals to 0.2 watt, 0.2 watt, 0.2 watt, 0.2 watt plus 0.1 watt equals to 0.9 watts. And then ang P source equals to IE excuse me, 0.1 ampere times 9 volt equals to 0.9 watts. So these are the several reasons why we would use multiple resistors instead of just one resistor with a resistance equal to equivalent resistance of the circuit. So perhaps a resistor of the required size is not available, or we need to dissipate the heat energy, or we want to minimize the cost of resistor. So each resistor may cost a few cents to a few dollars, but when multiplied by 1,000 of units, the cost saving may be appreciable. Excuse me. So that would be the equivalent resistance, current, and the power in a series circuit. So let's proceed to the problem set number 2, example 10.3, page 444 to 446. Excuse me. Analysis of a parallel circuit. 3 resistors R1 is equals to 1 ohms, R2 is equals to 2 ohms, and R3 is equals to 2 ohms are connected in parallel. The parallel connection is attached to a V is equals to 3 volt voltage source. A. What is the equivalent resistance? B. Find the current supplied by the source to a parallel circuit. C. Calculate the currents in each resistor and show that these add together to equal the current output of the source. D. Calculate the power dissipated by each resistor. And E. Find the power output of the source and show that it equals to the total power dissipated by each resistor. So these are the given. R1 is equals to 1 ohms, R2 is equals to 2 ohms, R3 is equals to 2 ohms, and the V is equals to 3 volts. Okay. Happy to mga full storage. So solution, these are the solution. So A, the total resistance of a parallel combination of resistor is found using this formula. So na siya, the equivalent equivalent resistance equals to I over R1 plus I over R2 plus I over R3, sorry, dayon, negative 1. So equals to, then ikuan na yun ka ng substitute, so 1 na siya, then equals to 0.50 ohms. So simple lang siya, ikuan na siya, i-add bitaw ang equivalent resistance, same atong problem set number 1. Dayon next sa letter B, I is equals to V over equivalent resistance. So atong V, which is given na is 3 sakit tila ako 3 volts excuse me, yun over 0.50 ohms, since di ba nakuha naman na to ang equivalent resistance. So i-substitute lang Japon. So the current supplied by the source of Ohm's law is equals to 6 ampere. Then proceed sa letter C. Excuse me. The individual current are easily calculated from Ohm's law since each resistor gets the full voltage. So the total current is the sum of the individual currents. So volts over R1 or resistance 1 is equals to 3. Atong volts is 3 volts over R1 is equivalent to 1 ohms. So then 3 in which equals to 3 ampere. So same lang Japan ang process ni na 1.50 ampere, then sa kani I3 excuse me 1.50 ampere excuse me sana makoy. Then letter D, then the power dissipated by each resistor can be found using any of the equation relating power to current, voltage, and resistance. Since all three are known, let us use P1 over V squared over R1 in which ang same ng Japan is substitute when siya itong volts 3 then squared over ang atong R1 is 1 ohms equals 9 watts. Then same ng Japan na siya, then 4 point ang atong P2 is equals to 4.50 watts or ato. Then ang atong P3 or power 3 in which equals to 4.50 watts. So same lang Japan siya i-manipulate the equation. So let's proceed sa letter E. The total power can also be calculated in several ways. Use P is equals to I over V. So then kanang total power can also be calculated in several ways. So choosing P equals I times V and entering the total current yields. So ang atong I in which di ba na ito nakuha sa letter B kanina is 6 ampere, then times din ang atong volts is 3 volts. So 6 times 6 ampere times 3 volts in which ang power na to is equals to 18 watts. So mura siya i-kuan lang. Then that would be all. Thank you. Kay full storage na ko. So let's proceed to the problem set number 3. So example 10.6 on page 459 to 461. Excuse me. Find the currents flowing into the circuit in figure 10.29. So as we can see from the problem set, no, so dito sa book is mo siya ang mga given. So R1 is equals to 1 ohm, R2 is equals to 5 ohms, R3 is equals to 1 ohm, R4 2 ohms, R5 is equals to 1 ohm, R6 is equals to 2 ohms. Then ang V1 is equals to 0.50 volts, V2 is equals to 0.60 volts, V3 is equals to 2.3 volts. So this circuit is sufficiently complex that the currents cannot be found using Ohm's law and the series parallel techniques. So it is necessary to use Kirchhoff's rules. So currents, so pang-label ang currents as I sub 1, I sub 2, and I sub 3 in the figure, and assumptions have been made about their direction. Location on the diagram have been labeled with letters A through H. In the solution, we apply the junction and loop rules, seeking the 3 independent equations to allow us to solve for the 3 unknown currents. So, applying the junction of the loop yields the following 3 equations. We have 3 unknowns, so 3 equations are required. So, junctions C is I sub 1 plus I sub 2 equals I sub 3. Then the loop A, B, C, D, E, F, A, I sub 1 times the quantity of R1 or the resistance 1 plus R4 minus I sub 1 times the quantity of R2 plus R5 plus R6 equals V1 minus V3. And the loop CDEFC I sub 1 times the quantity of R2 plus R5 plus R6 plus I sub 1 R3 equals V2 plus V3. So after that is we must simplify the equations by placing the unknowns on one side of the equation. So sa junction C, I sub 1 plus I sub 2 minus I sub 3. So sa loop A, B, C, D, E, F, A, so I sub 1 is kanang, diba, kay kanang atong R1 is kuan man, ang atong R1 is 1 ohm, dayon ang atong R4 is 2 ohms. So 1 ohm plus 2 ohms is equals to 3 ohms. Then minus dayon I sub 2. So I sub 2 dayon. Then same Japan is kanang R2 which is 5 ohms plus 5 ohms plus ang R5 is 1 ohm plus R6 is 2 ohms, in which 8 ohms. Dayon equals 0. Ang atong V1 dayon is 0.50 or 0.5 volts minus ang V3 na to is 2.30. So na siya. Then ang loop CD EFC 1 sub 2, then same lang siya po, i-add na to ang R2, R5 and R6 in which 8 ohms. Then ang kuan dayon then ang R3 is 1 ohm. Dayon i-kuan na rin siya, i-substitute ang mga values. So dayon in junction C, I sub 1 plus I sub 2 minus I sub 3 equals 0. So loop A, B, C, D, E, F, A, I sub 1, no? So so 3 ohms. Then ang I sub 2 is equals to 8 ohms. Then minus negative 1.8 V. Then loop C, D, E, F, C 1 sub 1 8 ohms plus I times 8 ohms plus I sub 3 1 times I 1 ohm equals 2.9 V. So ang result dayon niya is ang I sub 1 is anang 0.20 ampere, I sub 2 excuse me 0.30 ampere, I sub 3 is equals to 0.50 ampere. So kanang ang method to check the calculation is to compute the power dissipated by the resistors and the power supplied by the voltage sources. So PR sub 1 is equals to I sub 2 I sub 1 squared R1, then ano siya 0.04 watts. So siya, then excuse me, then ang PR2 which is 0.45 watts, PR3 is 0.25 watts, PR4 0.08 watts, PR5 0.09 watts, PR6 0.18 watts. So the power dissipated is equals to 1.09 watts. Then ang power source is equals to I sub 1 V1 plus I sub 2 V2 plus I sub 3 V2. Then kuan siya is 0.10 watts plus 0.69 watts plus 0.30 watts, and in which the power source is equals to 1.09 watts. So these are the currents flowing in the circuits. So muna siya. So let's proceed to the problem set number 4. Example 10.7 on page 461 to 462. Calculating current by using Kirchhoff's rules. Find the current flowing in the current in figure 10.30. So so anang this circuit can be analyzed using Kirchhoff's rule. There is only one loop and no nodes. Choose the direction of current flow. For this example, we will use the clockwise direction from point A to point B. Consider loop ABCDA and use figure 10.23 from the book is kanang to write the loop equation. Then note that according to figure 10.23 nga naa sa book is ang battery V1 will be added and battery V2 will be subtracted. So so as we can see no sa dato sa kuan kanang dato sa given sa book is mo ni siya ang given sa problem set. Then R1 is equals to 10 ohms, R2 is equals to 30 ohms, R3 equals to 20 ohms, then ang V1 is 12 volts, then ang V2 is equals to 24 volts. Dayon, applying the junction rules yield to the following equation. We have one unknown, so one equation is required. So loop ABCDA is equals to negative I 1R sub 1 minus V sub 1 minus I IR sub 2 plus V2 minus IR sub 3 equals 0. So simplify the equation by placing the unknowns on one side of the equation. So we kanang gamiton nato ang values sa kanang given sa figure dito sa book. So I times the quantity of R1 plus R2 plus R3 is equals to V2 minus V1. So I is equals to V2 no, so para makita, so para makuan nato ang I is ato siya kuan para makuan siya ato siya anang sana ato siya i-divide ang V2 kani i-move na to ang kani siya R1 kay para makita nato si I mo na divide na siya. Dayon, so V2 in which atong V2 diba ganina akong giingon is 24 volts, then ang V1 is 12 volts, diba kay katong ako ingon ganina is kanang ang V1 is i-add siya sa kuan battery, ang battery sa V1 is ma-add siya sa kanang ma-add siya, din ang V2 is mo na siya ang ma-minus. So mo na siya, din ang atong kuan lang nato i-substitute lang R1, R2, R3 which is 10 ohms plus 30 ohms plus 20 ohms in which na siya i-simplify in which is equals to 0.20 ampere. So the power dissipated or consumed by the circuit equals the power supply to the circuit, but notice that the current battery V1 is flowing through the battery from the positive terminal to the negative terminal and consumes power. So muna siya ang PR1 is equals to 0.40 watts, PR2 is equals to 1.20 watts, PR3 is equals to 0.80 watts, PV1 is equals to 2.40 watts. Then ang atong power dissipated is equals to 4.80 watts. Then ang power source is equals to IV2 is equals to 4.80 watts. So kanang ang power supplied niya is kanang equals to the power dissipated by the resistor and consumed by the battery of V1. So muna siya ang current flowing in the circuit that katong figure 10.30 dato sa book. So that would be all. Thank you so much.